Okay, section 3.1, we're going to talk about basic identities. And on this first page, as you can see here, we have a list of formulas. We have the reciprocal identities, which makes sense because cosine of x with the reciprocal is equal to the reciprocal of 1 over the secant, which means that secant is equal to 1 over sine. Okay, and so on. Then we're going to talk about tangents and cotangents in the terms of sine and cosine. Well, we know that tangent is equal to sine over cosine. That means the reciprocal, which is cotangent to tangent, is going to be cosine over sine. When we ever talk about Pythagorean, we always know that there's a Pythagorean theorem, and that is a squared plus b squared is equal to c squared. However, since we're talking about identities in trig, it becomes sine squared plus cosine squared equals 1. Okay, and then we have the cotangent and the tangent one as well. Now we're going to talk about odd and even identities. All the odd identities is going to be sine and cosecant, which makes sense because cosecant is the inverse to sine. Tangent and cotangent's odd. Well, it's because sine is a part of tangent. This means that cosine and secant is even. And we'll talk a little bit more about those. So in example 1, it asks you what is sine, cosine, or sine, cosecant, tangent, and cotangent. It is odd function. Example 2 said, let's find the product and simplify your answer. So we notice here that we have a binomial times a binomial. So we can use the full method, or we can just use the distributive method. We use the full method. We got our first times our first, which is 1 times 1. Now we put plus sign. Our outers, which is 1 times that cosine of alpha, plus our inners, we have a negative cosine of alpha times 1 plus the last. So now I have a negative cosine of alpha times a cosine of alpha. And now we're going to clean it up. I got 1 times 1 is 1 plus 1 times that cosine of alpha, which is cosine alpha. I have this positive times negative, so it's a negative cosine of alpha. And then I have negative times positive is negative. I have cosine times cosine, it's cosine squared alpha. And as you can see, I have a plus cosine and a minus cosine, so they go to 0. Leaves me with 1 minus cosine squared alpha. And if we go back up to our identities, we can determine what it is equal to. And let me give myself some space right here. So when I go back up to the identities, I can use the Pythagorean theorem's identity, where it says that we get sine squared. And I'm going to go ahead and put alpha instead of x, plus cosine squared alpha is equal to 1. So we can subtract the cosine squared of alpha from both sides. And now I got sine squared of alpha is equal to 1 minus cosine squared of alpha. And if y'all notice, this here gave me back what we found, right? So now that I found that, I know that it's going to be simplified. It's going to give me sine squared of alpha. So we found the product. Here's our product. And now we simplified it. And there's our end result. Okay? And that's all there is to that.
So
Okay.
question.
Sure.
So the answer for that one is just going to be what?
Sine squared of alpha. Because you got to
Okay.
simplify. So since I was able to simplify 1 minus cosine squared of alpha, then that means that wasn't my final answer.
Okay.
Okay, our next one says we're going to write the following expression in terms of sine and or cosine, then simplify. So we have,
Miss Wilson,
yes.
I have a question really quick. So how did you know which identity to use?
Okay, so since
Can you
I had
explain that?
cosine squared, I had
Mhm.
1 minus cosine squared. When I came up here to my identities, if you'll notice right here, we have cosine squared and it's involving a 1.
Mhm.
So I knew to use this identity.
Because of the cosine squared?
Correct.
Okay, gotcha.
If it would have been tangent squared, I would have used this one, or
Okay.
secant. Yeah. All right. This next one says we're going to write this expression and we're going to simplify it. On this little box here, I gave y'all the formulas or the identities. I mean, it's the reciprocals. So what we're going to do is we need to write this in a format that makes sense. So I'm going to look at the tangent here. Whoops. Now my eraser just don't want to erase. There we go. I'm going to look at the tangent here and write the tangent and the cosecant in a format that will work with cosine. Well, what do I know about I'm going to just do this. What do I know about tangent? Well, I know tangent is sine over cosine of alpha. And then the cosecant was reciprocal of 1 over sine of alpha. And it's all divided by the denominator, which is cosecant again. It's 1 reciprocal of sine, so it's going to be 1 over sine. Okay, so all I did was just rewrite it in a sine and cosines. Now I'm going to take and I'm going to rewrite it, use a little bit of basic math right quick. So I'm going to put in parentheses the numerator. All right. And then I'm going to say, oh, that divides the denominator. So I brought it out, rewrote it. Now, some of you are going to skip this stuff. You're going to actually keep change flip, and you can do that then. But I'm going to do it now. I was doing the extra step. All right. So now that I've got it written that way, what I can do is I can distribute the sine of alpha to each part. And what do I mean each part? This here is multiplied together, added to this 8. So I'm going to distribute to the 8 and I'm going to distribute to this parentheses. All right, so I'm gonna do an extra step. Again, you do not have to, but I'm gonna do it just so you can see what I'm saying. So now I'm going to say I got 8 times that sine over 1, and you could drop that 1 in the denominator. We don't need it, but I'm gonna leave it just for notation right now. It's gonna be this parentheses times that. We can separate it because of the plus sign because it's in 2 parts, but the multiplication part, I cannot break it apart yet. Now I'm going to go, okay, I notice that I have these 2 here going on. Isn't that a fraction? Well, could I not go ahead and put a 1 underneath this cosine? And then I can multiply straight across, right? Reduce if possible. So I'm going to go ahead and do that. 8 times that sine. Oops, don't forget the 8. of alpha plus, let's rewrite this. Oh. Okay. So now that I rewrote it like that, I can say, okay, what happens here? I have, let's reduce if possible. I have sine over sine, that's 1. Cosine over cosine, that's 1. Now I'm left with 8 sine alpha plus sine, because it's just all 1 times that sine, right? Now I can finish up. Whenever we add or subtract anything, you know, they have to be like parts, right? Well, if you agree, it says that 8 has sine alpha on it, plus we can say there's a 1 here times that sine alpha. We add those two together and we get 9 sine alpha. And that is our final answer. So that was all basic math right there. Okay, I'm going to move on if there's no questions. Okay, example 4 says use the identities to find the exact values of alpha for the remaining 5 trigonometric functions. Cosine alpha equals the negative square root 3/7, and alpha is in the 3rd quadrant. Okay, so in the 3rd quadrant of the unit circle, we know that both sine and cosine are negatives. That's to be remembered for our final answer on if we're going to have a negative or not. I'm going to work on the find the sine of alpha first. So what do we know? We were given cosine. So what I can do is go up to the top and say, okay, let's use the identity of the Pythagorean, where we have, let me write it up here. We have the sine squared alpha plus cosine squared alpha is equal to 1. However, we're solving for sine, so I can subtract the cosine squared from both sides. So now let's solve for sine squared alpha. That's 1 minus, and I know what cosine is. It's negative square root 3/7. But don't forget the square, because cosine squared. We only knew what cosine is, not cosine squared. Now you got 2 options here. You can leave this parentheses the way it is until we get further down, you know, or further along in the problem. Or you can say, let's go ahead and square everything in it. I know that negative squared is positive. Square root of 3 squared is 3. 7 squared is 49. Right? And we could say, oh, I want to clean this up just a little bit more. I want to go ahead and say that 1 minus this fraction. Well, I need a least common denominator, and our that's going to be in our denominator is 1 and 49. So it's going to be 49 times 1 over 49 times 1, right? Minus this 3 49s. And now I got 49 minus 3, which is 46 over 49. So I'm going to leave it alone, leave it as that, and that's what I'm going to use. However, we have sine squared, and we're wanting sine to the first power. So to undo the sine squared, I need to take the square root of both sides. And when I take the square root of this other side, since it's even, I'm going to get a plus or minus. Sine squared, it's just going to be sine. Or the square root of sine squared is just going to be sine alpha. We got plus or minus. I'm going to break this apart. I'm going to say square root of 46 over square root of 49. Well, square root of 49 is 7. And the square root of 46, well, it doesn't factor down no more than that. Not nice and clean. Is it negative or positive? Well, we're going to come back up here where it said that the alpha falls in the 3rd quadrant. In the 3rd quadrant, both sine and cosine are negative. So my end answer here is going to be negative. So my sign, let's get this down here, is going to be alpha is equal to negative 40, square root of 46 over 7. And that's my answer for that one.
Will
Okay.
they already have this sign alpha, or will we have to write that?
In my labs, it's literally going to make you answer in steps. So it's going to pop up. You got to solve for sine alpha. And then when you put in that answer, then it'll pop up the next one.
Do we not want to simplify it all the way? Like to reduce 46 square root?
If it'll reduce nice and pretty. The only time you want to put it in decimal form is if it asks you to approximate it around to the nearest whatever. However, this one here said give the exact value, so therefore the square root of 46 is just the square root of 46.
Okay.
But if you can ever reduce it, always simplify, always. Okay. Now, let's do the next one. Whoops. I was trying to, my mouse, 1 second. Okay, so now it'll work. There it goes. Now we're going to talk about cosecant. Now we all agree cosecant is the inverse of sine. So this is going to be easy. I'm not telling you this is the order my labs is going to go in. This is the order I went in. My labs may go in a different order. But cosecant of alpha, we know is 1 over sine of alpha. Well, what do we know that sine is? So I got 1 over negative square root 46/7, right? So in order to solve this, some of you already know to just flip it, right? And say 1 times that negative, well, I don't want to skip steps here. Some of you already have, and that's fine. It's 1 divides that negative square root 46/7. We're going to keep, change, flip. I get 1 times the negative 7/46, square root of 46, which is what? Negative 7 square root of 46. However, we're not supposed to have, now here, this is the answer. Negative 7 over square root of 46 is the answer. However, we're not supposed to have a root in the denominator, so we got to go one more step. We're going to multiply by the square root of 46 top and bottom. So now I got negative 7 times square root of 46 over 46. And that should be the final answer. Just watch. There was one time that I saw that it just wanted the reciprocal of it. So if it just wants the reciprocal, the identity and the reciprocal of it, then you wouldn't go any further. However, in mathematics, you always go reduce and simplify, okay? So just watch for that. Now, cosecant. Well, we know what cosine is, right? It was given to us at the beginning. I'm going to come up here and look at it. It was negative square root of 3/7. So the secant reciprocal of it is cosine, right? All right, so let's just plug it in. We got 1 divides cosine, we said was what? Negative square root 3/7. We're going to keep, change, flip. All right, again, if they just want the identity, the reciprocal identity, then we would say, oh, okay, the final answer is this. However, if they want you to simplify it and write it in correct notation, we're going to multiply by the denominator to undo that root. And then this would be my final, whoops, not the square root. then this would be my final answer. Okay, so just read what it asks for. All right. Now we have tangent to work on. Remember, tangent is cosine over sine. So cosine was what? It was, and in my notes, I actually stuck with the identity reciprocal. I can pull up my labs here in a minute and double check. Let me do that right quick, just because I want to see if they were asking you to leave it as the reciprocal identity or to actually simplify it. Just because when we do the tangent that we're going to plug in, all right. Okay, so they want
Can I
us.
see the work from secant again?
Yeah, yeah. Okay, good. Yeah, so in here in my labs, you're using the reciprocal, but they do want it simplified. So, there we go. So these are ones where, oh, I didn't even do that. Okay. Let's put that in negative. Back. Okay, these two, the ones that, well, not that one, but the one on cosine and sine. All right, sine is going to be a negative 46, square root of 46. Over 7. It's going to be divided by the negative square root 3 over 7. And then, I'm going to go ahead and do the basic math again. So I'm going to rewrite it. Negative square root 46 over 7 divided by the negative square root 3/7. And then we're going to key change flip. And what happens to our 7s?
They cancel out.
Yay, they go down to 1. And negative divides negative is positive. So now I got square root of 46 over square root of 3. However, we can't have a root in the denominator. So I'm going to multiply top and bottom by the square root of 3. Then that means inside this root, I got 46 times 3. So we can double check on that. So what happens to it? If I have the square root of 46 times 3. It just gets bigger. So it's just going to stay there. So now I have square root 138 over 3. Okay, yay. So that's my answer. As long as yes, it was 46. I'll double check my answer up here. Yeah. Okay, we're good. Now we're going to do the cotangent. When we do the cotangent, it's the reciprocal of tangent. Well, we know what tangent is, right? So we know this is 1 over tangent. So that means I got 1 over square root 138 divides 3. Rewrite 1 divides square root 138 thirds. Keep, change, flip. So now I got to undo that by multiplying top and bottom by the root. So now I have 3 square root 138 over 138. And what we want to do is see if that 138 will reduce by 3 because it was a product of 3. I noticed it did. So 3 goes in itself once, goes into 138 46 times because we did that right here. So now I got square root 138 over 46, and that is my final answer for cotangent. Yay. Okay. Now I'm going to try to keep my labs open just in case we come across another one. Now we're going to move on to our example 5. Just let me know if I need to slow down. Example 5 says simplify this expression. I got a negative sign, and in that parentheses, you see that negative on the X? So this tells me that we're talking about the evens and the odds, and we divided by cosine, minus sine over cosine with the negative inside it. So what we can do is recognize that sine of X, or negative X, we know it is odd, therefore it's going to give us negative sine of X. Cosine, on the other hand, is even. So that's just going to give me back my cosine of X. Okay. So now what we need to do is just go ahead and simplify this a little bit more. I got minus, and right here, this is a negative sine of X over that cosine, minus that sine of X over cosine of X. Well, this, oops, I was hoping the highlighter would come back. There we go. This minus and this minus becomes a positive. So now I have sine of X over cosine minus sine, oops, no, I didn't spell it right. Sine of X over cosine gives me 0. That's my answer. That's all there was.
Could you
Okay.
redo that one?
Rework it.
Yeah. Like, how do you determine like what to use?
Okay, hang on. Let me get my eraser. There we go. So let's start all over. So when I'm looking at this, it said to simplify this expression, right? Oh man. Sorry, my pen kind of got carried away. Okay. So when it said to simplify this expression, I saw that in here, right here, in here, inside that parentheses, my X is negatives, right? So we're going to talk about even and odds. So I'm going to come all the way up here, and I notice that here, right here, this is what I get. When sine of negative X, we get a negative sine of X because it's odd. And then right here, I notice cosine of negative X. Well, it's even, so it's just going to be cosine of X. So knowing that, that's what I'm going to do. I'm going to simplify and clean this up a little bit better. So I'm going to come back down here. I'm going to rewrite it. So now I have minus, and in the place of this sine of negative X, I'm going to put negative sine X over cosine of X minus my sine of X. And then in the place of this cosine of negative X, I'll just put cosine X because it was even. I noticed these two together, negative times negative is positive, left me with sine X over cosine X minus sine X over cosine X. And then I subtracted and it gave me 0. That help?
Yeah.
All right. Example 6 is show that the equation of sine alpha equals the square root of 1 minus cosine squared alpha is not an identity. Okay, so if it's not an identity, then it's not going to equal something that gives me back what we started with. So which of the following? We got A is pi, B is 3 pi halves, C is 0, and D is pi halves. And we want to know which one is not an identity. Well, what I know is, and just looking at this, that if I undo this square root right here, so I'm going to just work on simplifying this right quick. I got sine alpha is equal to the square root of 1 minus cosine squared of alpha. If I undo it by raising it to its power, that means I got to do the same thing over here. Now I have sine squared alpha is equal to 1 minus cosine squared alpha. And you notice this, don't this look like the identity of Pythagorean? So I could say, okay, well, let's get the cosine squared on the other side. Let's get it set equal to. So when I do that, I'm going to add this cosine to the other side. Get it to look like the identity, right? So now that I've done that, I know that this is what I have. It's equal to 1. So to be true, whatever I plug in, and I'm just showing y'all how I can see that it works. But you don't have to solve for it this way. But I noticed this here is the Pythagorean identity. So whatever I plug into this, in order for this to be true, I'll have cosine squared plus sine squared is equal to 1, or I'll have sine squared is equal to 1 minus cosine squared. So whatever I plug in has to give me back some kind of identity. So I'm going to erase this right quick, guys. I was just trying to let you see where I see this. So let's solve. When we solve for it, we know based upon the identity, we get what? You can solve for cosine, right, and plug in. I can say, plugging in these points into this here, I got sine alpha, and there's more than one way to do this. So in the place of alpha, what am I putting? I'm going to put pi. Is that equal to 1 minus, and there's more than one way, again, to do this. So what is sine pi? It's 0. So now I get 1 minus cosine, and in the place of, let me check this one out. Don't. Okay. Let's plug in cosine squared. Well, cosine of pi gives me what? -1. So I got 0 is equal to square root of 1 minus a -1. And -1 minus negative is going to be positive, right? So it's 2. So is that true? No.
Not
So
true.
we're not going to use A. So now let's go ahead and try out the next one. And again, some of you may use a different method and it's okay. So I'm going to plug this in and I'm going to see if the other side equals that. So let's plug that in. So now I got sine 3 pi halves. That equals -1. Awesome. Now let's try the other side. Cosine of 3 pi halves. That's 0. So now I got 1 minus 0. So now this says for B, it says -1 is equal to 1. That's not true. So let's try 0. So if I plug in sine 0 for alpha for sine, I get 0, right? So I'm going to get 0 is equal to, what is cosine of 0? It's
0.
1.
One.
Oh, it's 1.
Ah.
Oh.
Yeah, and that gives me 0.
Uh,
So I'm going to say C is correct. And let's see if there's one in my labs to look at right quick.
Miss Wilson,
Yeah.
I have a question. So you said that there's multiple ways to solve this. What are the other ways than plugging in like
You
the
can use some identities.
Okay.
Yeah. I was gonna see if I find one in our homework like this one. And I do not, but I do see one that I'm gonna talk to you about right quick. Okay, let's try this one. This one here may be the one that gives the most trouble. But that's how you can use the identities, pick an identity, and you notice there's a Pythagorean identity, and then you can see which side is true. I just plug in and does it equal each other? If it does, then it yielded out an identity. If not, then it's not. There is one though, before we do 7, I wanted to talk to you about right quick. So you're going to find one in your homework assignment that says, show the equation of, we're going to have 1 minus that sine beta squared is equal to 1 plus sine squared beta. And this might answer that question too. So basically, if one side is equal to the other side, then it's an identity. Okay. So this one we just did basically is plugging in, does it equal both sides? If so, then we got an identity. What if you're giving some equation and they said it's equal to this? Is it true? So you're going to have to work backwards on this one. So whenever we do this, we're going to have to remember that the identities, they satisfy every value of all the variables on both sides. If it does not satisfy them, like we just saw on the other one, then we know we don't have an identity. So on this one here, it says select something for beta for each side of the equation and evaluate it. So what if we considered pi force? Well, why do we want to do pi force? Because it's easy. It's cleaned up. It's easy. So you can pick either side you want to work on. But I'm going to pick this one because it's going to be a little bit less work. If you notice, this binomial has a square on it. So that means I'm going to have 2 binomials times each other. We're going to do a lot of distributing and stuff. And we may have to at the end, but I'm going to wait. Okay, so what I want to do is work on this other side that appears to be a little bit easier. So if I said I'm going to plug in and I'm going to pick pi force, and why? Is because I know that pi force on the unit circle is the square root of 2 halves, right? For this sign, that's what we get. I put a parentheses, I should have. But y'all know what I'm talking about. So I'm going to plug it in. So I'm going to say sine squared of pi force. That's going to equal 1 plus the square root of 2. And what happens? We have to pull this square on this 2. We have to acknowledge it. So I'm going to pull it out. Okay. And, oh, I apologize. In my notes, I actually solved the binomial one. Let's go ahead and do that. I know why I did. Don't erase this because this here we can still work with. What it is we're going to end up having, I mean, you go ahead and finish this side up. Let's go ahead and do it. I actually solved this one on the other side. I was thinking I saved it for later. But anyways, so now I'm going to clean up the middle right? If it can clean up, let's clean it up, and then we have that square going on. Or you can distribute either one, but I'm gonna clean it up. In order to add 1 plus this fraction, we have to have a common denominator, and I notice it's 2, so I'm gonna have 2 over 2, right? So now I have 2 over 2 plus the square root of 2 over 2. Now I can add these up, right? That gives me 3 square root of 2 over 2. So I got this going on. Actually, yeah, that's all right. I'm going about it a little bit different than how I did it before. So my answer there would be 3 square root of 2 over 2. Let's work it the other way too and
Where do you
compare
get
it.
the 3 square root of 2?
You're right. I was thinking it didn't look right. Thank you. Thank you. Because I was sitting here looking, I was thinking that
Wouldn't it be 2 square root of 2?
it'd be 2 plus. Yeah, because we can't add these two together. It'd be 2 plus square root of 2. And then you put it over 2, that gives me back 1. Okay, that's why, now I know why I went to this one on my notes. Okay, so y'all see this is what we get, right, by solving for this side. Do you agree? Thank you for catching that.
Can't you
Then we
divide
gotta
2?
square it. Huh?
Can't you divide 2 over 2 and get just square root of 2?
Hang on. And don't forget, we got that square on the parentheses. I could say this becomes 1. Whoops. This just gives me back my 1 plus the square root of 2 over 2 because the 2 reduces. We just get back to what we had here. And we still have the squaring on it, right? We're still going to have to distribute this square to everything inside there. So this is why I went to this one here, because it seems like we're just going back and forth. So we'd end up having to do this. You know, so let's not do this. Let's not, if we can avoid all that extra work, let's do it. So what I'm going to do is I'm going to save it. I'm going to put it over here on the side, and let's do work on this one. Now, if we work on this one inside this parenthesis, I got 1 minus that sign, pi over 4, which we know is 1 minus the square root of 2 over 2. And square it. We have a little bit more work going on, but now we have a subtraction going on. We can, let's see, what did I do? Said 1 minus. There's a little step here, which gives us back over here. So if you notice, let me highlight it so you can see it in my mess. We have 2 plus square root of 2 over 2. This one here is going to give us 2 minus the square root of 2 over 2 all squared. Let me think. Oh, I know what I did. I totally see what I did. I hope y'all saw it. I just saw it. All right. Y'all don't have to erase y'all's, just draw a line and go down underneath it. And maybe y'all saw it. I don't know. Thank you for catching the one typo here, but there is something here. If you'll look at this one right here. Come on, computer. What was squared? Only the sign, not the 1. So I should not have done this. I should not have done anything until I squared this right here. Y'all see that?
Yeah, that makes
Anybody?
more-
Yeah.
Yeah,
Yeah.
I see it.
I was sitting here thinking, man, what am I doing wrong? All right. So I got 1 plus square root 2 halves squared. Okay. I had one of these in my notes and I was wanting to dig a little deeper in it. But anyways, so now I have 1 plus 2 square root of 2 squared is just 2 over 2 squared is 4. And that gives me 4. Or we can reduce that, right? That gives me
1/2.
1 plus a half. Which just is 2 over 2. 3 halves. There's where my 3 came from. I was forcing a 3 that didn't belong, right? So now we need to see if this other side actually equals that. And if it does, then I got a true statement here. So on this other one, we can take the 1 minus that sign of beta and put in the square root. You don't have to, we can go ahead and do the pi for us. But then we can say 1 minus square root 2 halves all squared. Now this one's a little bit more work. So we got 2 options. We can, clean that up, or I can just say, oh, let's do the full method. So now I got 1 times 1 plus a negative or positive 1 times a negative square root 2 halves. No, we can't do that because of minus sign. Yeah, we can. I'm overthinking it. Plus 1 times that negative square root halves. And let me erase this right quick. All right. Let's do this. Okay. And then this last one is negatives. Oops. All right. Halves times the negative. Okay, so plus. There we go. Now I got 1 times 1. I got negative, or I got 1 times that negative. So I got this. I got this negative. And then negative times negative is positive. I got square root of 2 times square root of 2. That gives me 2. 2 times 2 is 4. So now I have 1 minus, and I have the negative square root of 2 halves minus square root of negative 2 halves. So I got negative 2 square root of 2 over 2 plus the 2/4. And I'm going to say, oh, okay. So the 2's reduce. 2 goes into 1, south, 1 goes into 4 twice. So now what I have, I got 1 minus square root of 2 plus 1/2. So let's put the 1 and this 1/2 together. So I know that I need 2 over 2 plus that half, which gives me what? 3 halves minus the square root or negative square root of 2. So that was a lot of work. Yeah, y'all do have one of these in your homework. So now what do I have? On this one side, I have 3 halves minus square root 2. And on this other side, I have 3 halves. And we're going to have to, let's see, pick. So let me show you right quick. You're going to have to pick the best option. So y'all got this written down. I'm going to take a picture and show you, and then y'all tell me which one would be the best option. So, we can rewrite it right here. What did we get? Okay. So now we're gonna have to determine what would be our best option. And in the problem, if they give you a pi or an alpha or something like that, you can use what they give you in the A, B, or C. And if you notice, they use the pi force as well. I wasn't even looking at those answers when I started in on this. So based upon what we're looking at, which one would be the best choice? Oh, and the example that I pulled this from came from so this would have been a plus sign right here because it was actually 1 plus the sign beta squared plus, or is equal to 1 plus sine squared beta. The other one I was working on had a minus.
So it'd
So
be
that-
D.
I agree. I agree with you too. So just do it in parts and take your time. Okay? Because you see how easy, and that's one reason I don't like ink pens is because it gets real messy, right? So when I write in pencil, I can erase. And so when I'm writing on here in my ink, for y'all to see, sometimes to me it looks messy and I kind of get messed up or get lost in my mess too. So anyways, okay. So I think that would probably be the hardest problem on this section, and it's just because it's just so much work. Is there any questions? Okay, if there's no questions, let's do our last example for this section. I'll stop the recording and then take a second to break, and then we'll go back on. All right. Example 7 says use the identities to simplify the expression. We got cosine squared alpha minus 3 sine squared alpha over 1 minus 4 sine squared alpha. So what do I see going on here? I got cosine squared and sine squared. Which identity do you think that we could use?
That'd be one of the trig. It'd be one of the trig functions, one of the Pythagorean
Yeah,
functions.
yeah, very good. We can use this. Okay. So we got an option here. We can solve for cosine or we can solve for sine and just plug in. I'm going to solve for cosine. And the reason why I choose cosine is because I got sine here and I got sine here. I only have one cosine going on. So let's just do solve for cosine and plug it in. That way they're all 3 sines. All right. I'm going to do that. That means I'm going to subtract the sine squared from both sides. And now I know what cosine is. So I'm going to rewrite this. And in the place of cosine squared, I'm going to put 1 minus sine squared alpha. And then I'm going to write minus 3 sine squared alpha all over 1 minus 4 sine squared alpha. And now I'm looking at this and I see that I have this negative sine squared alpha minus 3 sine squared alpha. So it's the same as saying I'm in the whole $1 and I spend 4. So now I got 1 minus 4 sine squared alpha, all divided by 1 minus 4 sine squared alpha. And then my answer is
1.
very good, 1. Okay, I'm going to stop the recording.